Welcome to everybody who came today. My name, as Renee said, is Laura Bowman, and I'm a lawyer with the law firm Iler Campbell. My background is working mostly with different non-governmental organizations who are dealing with nuclear applications in their communities. And so Renee asked me to put together a little piece comparing deep geological repository regulations in different countries. This is a little disclaimer. A lot of the approaches that different countries take to this issue are really apples and oranges. So I've simplified things a little bit so that they're easily compared to the Canadian regulatory context. So some things may not be a perfect comparator point to what Canada does, but they're at least on the same topics. And obviously I'm not a lawyer in Sweden or the United States. I'm a lawyer in Canada, so some of the regulatory issues in Sweden and the United States are changing all of the time, and so I can't swear up and down today that I have the absolute latest, most up-to-date information from either of those countries. With respect to some of the things I'll be talking about today, regulatory documents often make a distinction between storage and disposal, and I'm not going to get into a level of detail where I'm worrying a lot about whether or not the regulation covered just storage or storage and disposal or just disposal, but I will be comparing things that deal with either or. And obviously, different countries have lots of different nuances in how they model radiation doses and how they come up with their dose estimates. So a dose estimate in one country is not necessarily directly comparable with a dose estimate in another country. So I just wanted to highlight that for you so that when we're comparing dose requirements, keep in mind that they're not always directly comparable in an easy, straightforward way. So specifically, Brené's asked me to talk about different country approaches to the safety case. Well, what is the safety case for a deep geological repository? Safety case is defined both by the Canadian Nuclear Safety Commission and the International Atomic Energy Association as an integrated collection of arguments and evidence to demonstrate the safety of a facility. It's a little bit difficult to know exactly what that's supposed to mean, but it clarifies that this includes both a safety assessment and arguments about the robustness and reliability of the safety assessment and what assumptions, and it also mentions uncertainties, are contained in the safety assessment. So you have an assessment of safety on the one hand, safety cases, the safety assessment, and all of the arguments around why the safety assessment is adequate. The International Atomic Energy Agency has described a safety case as an iterative process, and by that they mean that it should change with each stage of the project, becoming more detailed with each regulatory decision. They also discuss a few things that I'll highlight in their literature on the safety case, which is that a safety case should avoid risk dilution for improbable major risks, which means you shouldn't discount the risk of a major accident that is unlikely. You still have to include that in the assessment. They also require that a safety case transparently addresses uncertainties in scenarios, modeling, and data input. So the whole idea is that we know the safety assessment won't be perfect, but the safety case should explain what are the holes in the analysis, why is this an acceptable assessment. They also require what's called a deterministic assessment of certain kinds of dose risks from contaminant migration, which means it's not good enough to say that either it's unlikely that the contaminants will migrate or it's unlikely that anyone will be exposed to the contaminants. if they migrate, you have to do an assessment of what will happen if that occurs. A safety case should also integrate things like mine safety and occupational health and safety. It should include a rated approach, so the magnitude of the radiation risk and the stage of the project will determine how detailed the safety case should be. The safety case should describe the disposal system, describe the safety strategy, and deal with issues of defense in depth. Now, I'll note just for the record, it's not spelled out in my slides, Canada is a signatory to the joint convention that the International Atomic Energy Agency administers, and all of this material is contained in guidance documents to assist countries with compliance with the convention. None of this material from the International Atomic Energy Association creates any kind of mandatory rule that Canada is bound to follow. It just gives us a sense of what the international standard is for safety case. So, International Atomic Energy Agency has a specific document, SSR5, that describes what should be included in the scope of the safety case. These are some of the things that need to be within the scope. I think one interesting feature of this is the managerial control measures, and that it shall provide assurance that to the regulatory body and other interested parties that the safety requirements will be met. SSR 5 spells out how the safety case has to be described, that it has to be at a level of detail and quality sufficient to inform and support the decision to be made at each step. So what it envisions is someone has the high-level idea, there are several regulatory steps involved in approving that idea, and that at each step the safety case will get more detailed. They also emphasize that safety shall be ensured by passive means, and the need for actions after closure shall be minimized. So the international standard is that you aren't constantly going down into the deep geologic repository after it's been closed to fiddle around with things. You're not creating engineered barriers that need maintenance that you have to go in to do. The whole thing should be designed as a disposal facility that you seal off and you walk away from. The International Atomic Energy Agency also suggests both a dose constraint and a risk constraint. They spell out things that need to be considered with respect to the use of a representative person to calculate the dose, and they also spell out expectations for doses when there's inadvertent human intrusion. And basically, this corresponds to what the dose in an accident would normally be. So they treat inadvertent human intrusion similarly to the way that they would treat an accident. Now, there's also some discussion in here of the time frame of the assessment. This includes that containment shall be provided for the radioactive waste until radioactive decay has significantly reduced the hazard. Again, they're emphasizing active institutional control shouldn't be what you're assuming is going to happen way into the future. Short-lived waste, they envision several hundred years of containment and several thousand years for intermediate and high-level waste is the time frame that the safety has to be assessed on. Specific Safety Guide 14, published by the International Atomic Energy Association, or agency, provides that the safety case for the period after the facility closure should address scenarios over very long time periods. For example, the period comparable to that over which the waste remains hazardous. So, not left to the student as an exercise to decide what the time frame should be. There's specific guidelines in the International Atomic Energy Association, or agency's documentation. So what does Canada do? Well, the Canadian Nuclear Safety Commission follows generally the approach spelled out in specific safety guides. And this is found in a couple of different CNSC regulatory documents, G320 and P290. P290 is really just a few principles taken from the Joint Convention, very specific, so I won't be talking about P290. G320 is a very soft guidance document that doesn't contain any specific requirements. And then after that, you're left with the regulations in the Nuclear Safety and Control Act, which basically deal with dose. The Canadian Nuclear Safety Commission standard is, does the application have an acceptable impact on health, safety, and the environment or national security? It doesn't have any concrete standards of any kind for either design or design outcomes except for the public dose. They have 1 millisievert per year public dose. They also have a 0.3 millisievert dose constraint, which they use as a proxy for what is as low as reasonably achievable. So they assume that 0.3 is the same as low as reasonably achievable. If the dose is going to be more than that, then you have to justify why that is also as low as reasonably achievable in the context of your specific application. That's really all there is. There are no other requirements in Canada, that at least none that are spelled out in the regulatory context, and with the exception that G320, the CNSC guidance document, does adopt some external standards respecting non-radioactive hazardous waste. Really, Canada's approach is that the proponent of the Deep Geologic Repository has to come up with their own way of designing and ensuring this thing will meet the public dose requirements. They have to come up with their justifications for whatever methodology they use. G320 requires that they look at scenarios including human intrusion, and they require that the predicted impact is no greater than the impact that is permissible in Canada at the time of the regulatory decision. So that suggests that the 1 millisievert public dose is the impact that's expected. At least during the license period, it's not entirely clear if that would extend to way post-closure, say 1 million years from now. Again, with respect to dose modeling, Canada really doesn't tell you how to define the critical group, which is the same as the reference person in the international documentation. There's no guidance on how to deal with the critical group or model doses for the critical group, at least none that are specific to deep geologic repositories. There is some guidance for this for nuclear power facilities, but those guidance documents don't apply. Canada lists the analysis that needs to be done for the safety case, but not how to do the analysis. So they include the same laundry list of topics that the International Atomic Energy Agency includes. Way less specific guidance is given and no methodological constraints are imposed. They also suggest, although human intrusion has to be considered, that it's unlikely, right in the guidance document, and that if it occurs, dose limits can be exceeded because it's very uncertain. So already they're resiling from what the International Atomic Energy Agency put forward, which was that it's an accident scenario basically that needs to be considered within dose limits for an accident scenario. With respect to the time frame of the assessment that Canada foresees proponents putting forward in a license application, timeframes have to include the period of time during which the maximum impact is predicted to occur. Well, that prediction is entirely up to the proponent. The proponent predicts the time frame where maximum impact is predicted to occur is for the next 3 weeks, and that after that it will be less. That's the period of time G320 requires. It's 3 weeks, assuming that the proponent can justify this to the regulator. And unlike the International Atomic Energy Association documents, Canada explicitly permits institutional controls to go on for more than a few hundred years post-closure of the facility. It's not clear what they mean by institutional controls. In many places, passive institutional controls, things like keeping records, are permitted, but G320 makes no distinction really between active things like maintenance and passive institutional controls. And in any event, it's all discouraged by the IAEA a few hundred years post-closure. You're not supposed to assume that that's possible. The details of the time frames do matter. What is it that you are evaluating on what time frame? Are you just looking at whether or not the geology will be stable for 1 million years? Are you looking at climate change for 1 million years? Are you looking at whether or not the engineered barriers will last for 1 million years? Or are you looking at all of these things on different time frames? What time frame are you looking at operational or institutional controls for? Usually you won't be looking at them for 1 million years because you're assuming that passive barriers take over shortly after the facility is closed. So just because somebody says, well, we've looked at this project for 1 million years, doesn't mean that everything is included in that and that's something to be alive to. With respect to how does Canada deal with each of these subsets of issues, G320 describes that climate change or earthquakes, glaciers need to be taken into account in the assessment, but only insofar as that's necessary to justify the time frame used by the proponent. So there's nothing in Canada saying to look at these things for 1 million years. The proponent has to examine these things and justify the time frames that they've picked related to them. So what happened when the Bruce Deep Geological Repository environmental assessment set out a couple of ways that they dealt with it? First, they said that none of these things were likely to impact the project. And then they said the safety case reviews the integrity of the geology to contain and isolate the waste at time frames on the order of 1 million years. So that's just geology. They also use 300 years post-decommissioning institutional control. Again, not totally clear to me from a regulatory perspective how much institutional control is it passive or active, etc. In all cases, the potential impacts they predict become small on the timescales after 60,000 to 100,000 years. Well, that's very nice, but does that mean that that's the period of maximum impact as per the regulatory guidance? I don't know the answer to that, but I'm just highlighting how people have applied G320 so far. In other countries, they, of course, have also had to deal with what to do with radioactive waste and bury them in deep geologic repositories. I've only looked at Sweden and the United States. There's no magic to those selections except that we knew that there was some information available about them when we decided to do this presentation. Now, Sweden has a set of regulations called the SCIF, and these encourage, similar to the international documentation, deterministic methods for various items. This is just one example, but there are many within the Swedish regulations that suggest that just assessing the probability of something to decide if you want to assess the effects of it might not always suffice. There are specific parameters around the critical group or representative person that you need to choose to calculate doses. Unlike Canada, which never uses this methodology to my knowledge, you have to pick the group that would receive the highest dose as a result of the presence of the repository. Now, one could go beyond this and say that this requires that you use a fence line or somebody who actually goes into the facility by accident in a human intrusion scenario. I don't know the details of how Sweden applies this, but at least they give some direction to proponents about how to pick the critical group features. In Sweden, they also have a prescribed time frame for different types of waste. High-level waste, entire feasibility of isolating the waste must be evaluated for 1 million years post-closure. So it's not just, will the geology be stable for 1 million years? It's how feasible is it that this high-level waste will be isolated for that period of time? It's a much, much more difficult question to answer than we have anybody even attempting to ask in Canada. And it's 100,000 years for low and intermediate level waste. Compare that to the 60 to 100,000 year period that is being used in the Bruce DGR. And that's not necessarily for everything. Some of the evaluations go on for even longer than that in Sweden. That one has quantitative evaluations are modeled for 10 million years. So yes, after 1 million years, maybe the feasibility of isolating the high-level waste isn't an issue, but what are the effects after that period? And then there's an issue of what period of time you need to have complete containment for, and that's 1,000 years. They specifically require that the next glaciation cycle be taken into account in the climate analysis. We don't have anything like that here. With respect to projection objectives, they're very strict about the passive control that needs to be implemented, and also they want it sealed within a few years. They don't want something where, well, maybe we'll seal it in 100 years, or maybe we'll seal it in 50 years. They want something, you put it down there, you can close it off, and that has to be feasible. Because, of course, the risk is that the thing is designed to be closed, but you never end up being able to close it. There's another set of regulations in Sweden called the EKRA, and it deals in some detail about things like how well you have to be able to control the waste, whether or not it needs to be retrievable in different periods of time. They also have specific regulations concerning safety and disposal operations. They have a variety of guidance documents related to the EKRA that deal with deep geologic repository related issues. They have protection objectives for radiological risk that have a more strict appearing dose constraint in Canada. Canada's 0.3, they're 0.1 millisieverts per year in projection objective 1. Again, I'll put some caution brackets around and how you calculate the dose, whether or not that's going to be stricter or not. The radiological risk from the facility has to meet a specific risk criteria left up to the proponent in Canada. And basically 1 in a million, which is comparable to any other public health standard. They also set out different kinds of scenarios that have to be assessed. They require that several independent experts should assess probabilities, not just one. they require all kinds of things to be specifically quantitative analysis of things like possible dispersion of radioactive substances, how it's distributed over time, and sequences of events. So they don't want just some general commentary about, well, this is what we think is likely to happen. It's very unlikely that this will happen, but even if it does, the dose will be such and such. They want you to spell out scenarios and quantitatively analyze them in a transparent manner. And they expect that a number of future scenarios for inadvertent human impact or intrusion will be presented in the safety case. So that, unlike Canada, they're not saying, well, it's very unlikely, and if you exceed the dose, don't worry about it, because no one's going to ever intrude in it anyway. Moving on to the way the U.S. deals with this, in Yucca Mountain, the Environmental Protection Agency has drafted specific regulations just for Yucca Mountain. We have nothing like that in Canada. The Nuclear Regulatory Commission also has regulation that's specific to the Yucca Mountain repository. There are specific standards for human intrusion. There are specific standards for groundwater protection. There are spelled out standards for the protection of individuals just at Yucca Mountain. They have the same or similar general standards to what the Canadian Nuclear Safety Commission has, which is a reasonable expectation that compliance will be achieved. But Canada, it's just in relation to health, safety, the environment, national security as general subject matter. Here, it's a reasonable expectation that these specific requirements will be met. They have groundwater standards for different types of radionuclides, specific to Yucca Mountain. They have a number of specifically laid out modeling methods that they require to be conducted. They have things that they have decided already are likely or unlikely. And how you decide when a probability meets the threshold of being unlikely, and you don't have to include it. In the U.S., they judge compliance against 150 microsieverts per year up to 10,000 years after disposal, and then up to the full public dose after 10,000 years to 1 million years, and that was highly contentious when that was put into place, because of course that means future generations are getting the full public dose while everyone right now only gets 150 microsieverts per year. They have various justifications for that. They have specific risks spelled out of 50-year lifetime risk of I guess that's less than your typical public health standard by quite a bit, but still reasonable. They also require the effects of climate change, earthquakes, volcanoes, and corrosion to be assessed during a 1 million year period. They have a safety analysis report that has specific requirements that it must meet. They have prescribed modeling items like what is the biosphere projected to look like in future scenarios, what does the control or reference or critical group person look like for dealing with dose modeling. So what conclusion can we draw from these differences? Well, in Canada we don't have the groundwater standards the U.S. has. The U.S. and Sweden have more specific modeling requirements spelled out, or at least specific guidance provided on how to do modeling than we do. And some of the guidance that Canada gives to applicants for the Geological Repository really does differ from the International Atomic Energy Agency on risk assessment issues, like is risk dilution acceptable? Because to my reading of Canada's documentation, it is acceptable. And with respect to design, there's really a total absence of physical design objectives in the Canadian regulatory context that are being spelled out. Really, all there is that reasonable risk and 1 millisievert per year public dose. Maybe the dose constraint and as low as reasonably achievable. Whereas specific design objectives are actually spelled out in the specific safety guides at the international level. I would say that having done this comparison, no one has meaningful design standards for engineered barriers in a deep geologic repository. That shouldn't be too surprising since no one's built one yet. How will they know what the design standards should be? But on the other hand, we have been building mines for a very long time, and so one might think that some design standards for at least constructing a safe repository might exist or be incorporated somewhere. I haven't seen it if it exists somewhere in the world. Now, with respect to the time frame, Canada, I would say, is fairly described as an outlier in that it contemplates institutional control for lengthy periods post-decommissioning. Whether or not proponents actually do that is to be seen. Bruce didn't really go, it went up to 300 years. I didn't go longer than that. The problem really is mostly that proponents have total flexibility on what timelines they use for various features through the environmental assessment process, and how transparent will their use of timeframes be. It really doesn't, it's really not apparent from looking at G320, the Canadian Nuclear Safety Commission document, whether or not the specific safety guide standards set at the international level are being met or attempted to be met. And the approach to how to deal with future generations, which is part of the Joint Convention on Disposal of Nuclear Waste, differs between everybody in a pretty significant way. The EPA probably has the most detailed rationale for how it deals with that compared to everybody else, but there's acknowledged widespread disagreement about how to address that issue at the international level. And that's my last slide, so I'd love to deal with any questions anybody has. I'm just going to go back to the first slide so that people have my contact information. I think we forgot to put the contact slide in at the end here. And I don't think that the chat function is turned on fully.
I'm just about to restore the chat function now. So thank you, Laura. That was very helpful. And I've got people's microphones muted on this end, but I think, let me check. Diane, no mic is available. Lynn has muted herself, and Cynthia, I will unmute you now. We seem to have lost Rob in the course of the last several minutes. So thank you very much, Laura. And any questions or comments, and feel free to either, Diane, I guess you can't, you'll have to put your questions in by, or comments in through text. And any other comments or questions?
I have a question from Samantha here.
Hi, Samantha.
I was just wondering, because in this presentation, Laura has noted, that there's a lot of to me, I think it looks like the Nuclear Waste Management Organization is not, quite up to par as the rest of the world in managing nuclear waste. What I guess would be how can she or mobilize this information to be able to change standards and regulations and stuff like that, to be able to, I guess, follow along with the rest of the world and how they're managing nuclear waste?
Well, I think this probably will come up when there's that environmental assessment proceeding, also during licensing before the Canadian Nuclear Safety Commission. The Nuclear Waste Management Organization is really, truly a regulatory body that would be dealing with any of this stuff, at least not as a regulator.
Mm-hmm.
And it's challenging because Canada in general, at least compared to the U.S., does tend to spell out requirements.
Mm-hmm.
That the proponent will show up with a relatively complete application, work with the NSC staff in those details, and a lot is going to be left to CNSC staff to decide what is enough. And I'm sure that they do look to these energy associations requirements when they do that, but really then the issue there is going to be transparency, right? Backroom conversations about whether or not it meets this or that standard with staff, and how does anybody else know if it does? So one way is just to keep pushing the CNSC and try to embarrass them about how little, or about how few transparent requirements there are.
Yeah. The Canadian Nuclear, what did you say it was?
Safety Commission.
Safety Commission.
They have the power to enact regulations about deep geologic repositories if they want to.
Mm-hmm.
Done that.
And one of the issues that Bernane, one of our concerns is there's a service agreement between the Canadian Nuclear Safety Commission and the Nuclear Waste Management Organization, through which the Canadian Nuclear Safety Commission provides some services to the Nuclear Waste Management Organization, like presentations to the communities who are being studied as possible burial sites and services like that, but also of concern, Diane has just added that the CNSC will come to your community and do workshops, and that's part of the service agreement. But the part of it that is of concern to us is that there's also a sort of a discussion between, so this is between the proponent and WMO and the regulator, on what the evaluation standards will be. So there is an ongoing back and forth between, so basically it's a pre-design.
It's like an arm's length type of thing.
Well,
back and forth.
Yeah, and so we have a concern about the lack of transparency there. So there is only, as Laura's outlined, the G320 is the main sort of standard in place in Canada, and it was reviewed a few years ago, and the standards and the regulations and the guides are reviewed from time to time by the CNSC, and there is an opportunity to comment on that. But we have a concern about what's happening, before it comes to the public, because it's very difficult. If you go back and forth with your friend about how much you're going to, sell your bicycle for, and you've agreed on a price, and then you ask your sister for her input on the price. Well, if you've already agreed, it's kind of, you're not likely to change your mind because you've already got an agreement.
Mm-hmm.
So it's that kind of pre-design approvals that we're concerned about within that service agreement between the CNSC. Lynn had a question around, question from Lynn Morgan. Can you tell me, please, Laura, if there are any regulations relating to how the waste levels are determined, high, medium, and low? And thank you. So Lynn's question is about how the waste is categorized into those low, intermediate, or high-level waste categories in Canada. Laura, can you speak to that?
It's not really regulatory set of terms in Canada, like not in the actual CNSC regulations. But Canada does have sort of Canada does have guidance on how you categorize different kinds of waste. I would actually think that, Bernane, you know more about that than me. I usually come up against this when I've got a specific regulatory threshold. It doesn't always
the categories generally they can be described this way. The low-level waste is waste that doesn't require shielding. So there doesn't have to be a barrier between an individual and that waste and so that's mostly a definition in terms of the gamma radiation that's being emitted from that low-level waste. And then the intermediate level waste is all waste that isn't nuclear fuel waste. So in Canada, the category of intermediate includes everything once you pass that threshold, and there is a measure in becquerels of that threshold, and the number's just escaping me at the moment, but basically that threshold is set around an assessment of when you would need shielding, and then it becomes intermediate level waste, and then all waste that isn't fuel waste is considered to be intermediate, and that's why some of the intermediate level waste, which is proposed to be placed in the repository, geological repository that's being put forward as a proposal for under the Bruce Nuclear Generating Station. It's called intermediate level waste, but it's actually highly radioactive, especially things like the resins and filters and so on from the reactor station are actually highly radioactive, but they're classified as intermediate or medium because they're not fuel waste. And that's similar in other countries as well. In other countries, in Canada, if it's high-level waste, it's nuclear fuel waste. In other countries, high-level waste will include also weapons waste and reprocessing waste. But because we don't have reprocessing or weapons production here, our high-level waste is all the nuclear fuel waste.
Well, can you tell me then if there's really no distinction between the radioactivity level between some intermediate waste and the high waste, then are the regulatory standards different for the burial of the intermediate waste versus the high level waste? The waste that has been classified as high level waste.
Laura, can you speak to that? And I can add a comment.
I think the only place I've seen a place where that kind of threshold gets engaged is environmental assessment. There's, in the past, the regulations have set out a specific becquerel threshold for comprehensive studies, but of course that whole regime. I remember thinking they might have changed the threshold in the new environmental assessment regulations, but to be honest, I would have to check whether or not they did that or not. Renee, I don't know.
Yeah, so I know there are some differences, and I'm just clicking through Laura's slide. She did have a slide where she mentioned in Sweden there is a different time frame for low and intermediate level waste than there was for the high level waste. Now I can't find it. But Laura, maybe you can recall that. But one thing that has really struck me, here's for Sweden, the time frame is 1 million years for high level waste, 100,000 for low and intermediate level waste. So there does seem to be a tendency, both domestically and internationally, to treat low and intermediate level waste as if it's low. but the intermediate, some of the intermediate is highly radioactive, as highly radioactive as some of the fuel waste. What has really been interesting in the Bruce, using the term interesting in a kind of a euphemistic way, internationally, the emphasis is on this multi-barrier concept, and so it's a combination of the fuel container, an engineered barrier, a buffer material, and the rock. But in the Bruce proposal in the Ontario Power Generation's proposal for the barrier low and intermediate level underneath the Bruce, there is no engineered barrier in their design. The waste will be in the containers that they're in, but when they talk about multiple barrier, there in their descriptions, they're talking about 2 layers of geology. So there's the limestone where the repository, the caverns will be constructed, and then an overlay of shale. So the Bruce repository for low and intermediate level waste is, it's very interesting how it's being presented, and it's quite different from others. The other difference is internationally, it seems the other low and intermediate level repositories are actually classified as storage, not disposal, which means if it's storage, it means it's below grade, but there's an intention to be able to retrieve it indefinitely, versus the Bruce DGR, the OPG's DGR at the Bruce, the intention is permanent placement or disposal. So
I've pulled up the environmental assessment regulations just out of curiosity, and I can tell you that they do have in the new thresholds for when an assessment does or does not occur, a threshold radiated nuclear fuel specifically. And that is to the power of 15 becquerels a year of a half-life greater than 1 year. So I don't know what that works out to insofar as how that compares with how they define high-level waste anywhere in their guidance documents, but I would suspect that is what that is aiming at. But they require an assessment for all disposal. So if it's storage, there's a threshold. If it's disposal, there's a threshold.
Thanks for those questions, Lynn. Any other questions, comments? The environmental assessment for which project, Samantha? For the Bruce Deep Geological Repository that I was talking about?
Mm-hmm.
Yes, it is. If you go, it's on Ontario Power Generation site, but I'm going to type in, if you go to www.brucenuclearwasteburial.ca. That's a website that is a collaborative among different public interest groups who are participating in that review. And it's easier for me to send you to that link, and from there is a link to the environmental assessment documents. And there's also, because the hearing is underway, or the review is underway, the hearing hasn't been announced yet, but it will follow. And it will, there is a public registry. So there's lots and lots of things posted on it, but the public registry, which is operated by the Canadian Environmental Assessment Agency. So it's like an online data bank of everything that every organization submits. And there have been some excellent submissions by Saugeen Ojibwe Nation, who are, it's on their territory, the project, and they've submitted some. If you go on, you know what, Samantha, I'll send you a link to it. There's back in August, early August, Saugeen Ojibwe Nation put in a submission which was a very good summary of issues in that area. You would also like that, Lynn, because one of the issues Saugeen Ojibwe Nation is raising is the absence of any kind of cumulative effects assessment. So there are communities being studied for burial of the high-level waste, and there's this proposal for burial of the low and intermediate level waste, and the review processes don't intersect. Oh. Oh, thanks, Laura. You reposted that. I put the link out only to Laura, which she probably already had. Thanks for reposting that. Other questions, comments? Any final words of wisdom for us, Laura?
I guess I would just say that Bernard and I are scheming to put some of this into a more formal report format, so that it can be, you can find all the references to all this stuff more easily. Keep in touch with Bernard about that, so that you can get a hold of that if you want it. And other than that, I think it's a wrap.
Okay.
I have one last question.
Sure.
Earlier you'd mentioned that it's open for comment from any kind of regulatory changes or new ones, I guess you could say, from the Canadian Nuclear Safety Commission. Where is that available at?
Well, if and when they put out a guideline or a regulation for public comment, it's posted on their website, which is nuclearsafety.gc.ca. You can also get on an email list if you go to that website. If you go to that website, then you can ask to be added to an email list, and then you'll get email lists. Now, they send out a lot of email. So, and if they, Laura just got it. And I was just typing out the shorter version.
Okay.
So that's the Canadian Nuclear Safety Commission's website, and they did do a review of G320. Do you recall, Laura, was it 2003 or 2005?
2006 was when
2006.
they finalized the new one.
Oh, wow.
So,
but that's I'll just note that was 6 years before the International Atomic Energy Agency updated its specific safety guide.
Okay.
And typically they should be reviewed and revised about every 10 years.
Yeah.
Typically. Now there are many there are different guidelines that are brought forward, and sometimes they're brought forward by the Canadian Nuclear Safety Commission. Sometimes they delegate to the Canadian Safety Standards Association, the people who make sure our toasters are safe and all of our screws have the same size of hole. The Canadian Standards Association does some of that review process. It's not literally correct to say they're doing it for the for the Canadian Nuclear Safety Commission, but they develop a standard which the CNSC then adopts or refers to.
Mm. Okay.
But don't worry, Samantha, you haven't missed a thing. It'll come around again.
Okay, well, I think that's all my questions that I had.
Okay. Well, thank you so much, Laura, and thank you all for spending the afternoon with us. And I will be sending around a very brief survey to get some feedback on the February series and also some ideas for a spring and a fall series. So thank you all so much for participating in these webinars, and thank you, Laura, for your very good research and presentation. It's been very helpful.
Yeah. Thank you all for everything. Good conversation and presentation. Again, Laura, thank you.
Put my email up because we forgot to put that in the presentation.
Okay.
If anyone wants it.
And I'll just...
Is that an I after the at?
Yes.
And I've just put up the website, nonuclearwaste.ca, and we will be posting documents that we've referred to through the webinar series. So the links are being added to that website. For this presentation and the last presentation, it will be posted on the page about geological repositories. So again, thank you so much, and we'll be in touch. Thanks, Laura. Thanks, everyone.
Bye.